content, uh, diagnostic tests. The book begins with four diagnostic tests in basic algebra, analytic geometry, functions, and trigonometry. A preview of calculus. This is an overview of the subject. It includes a list of questions to motivate the study of calculus. Chapter 1, Functions and Models. From the beginning, multiple representations of functions are stressed: verbal, numerical, visual, and algebraic. A discussion of mathematical models leads to a review of the standard functions, including exponential and logarithmic functions, from these 4 points of view. The material on limits is motivated by a prior discussion of the tangent and velocity problems. Limits are treated from descriptive, graphical, numerical, and algebraic points of view. Section 2.4, if I didn't say this was Chapter 2, Limits and Derivatives. Section 2.4 on the precise definition of a limit is an optional section. Sections 2.7 and 2.8 deal with derivatives, especially with functions defined graphically and numerically, before the differentiation rules are covered in Chapter 3. Here, the examples and exercises explore the meanings of derivatives in various contexts. Higher derivatives are introduced in Section 2.8. Chapter 3, Differentiation Rules. All the basic functions, including exponential, logarithmic, and inverse trigonometric functions, are differentiated here. When derivatives are computed in applied situations, students are asked to explain their meanings. Exponential growth and decay are now covered in this chapter. Chapter 4, Applications of Differentiation. The basic facts concerning extreme values and shapes of curves are deduced from the mean value theorem. Graphing with technology emphasizes the interaction between calculus and calculators and the analysis of families of curves. Some substantial optimization problems are provided, including an explanation of why you need to raise your head 42 degrees to see the top of a rainbow. Chapter 5, Integrals. The area problem and the distance problem serve to motivate the definite integral with sigma notation introduced as needed. Full coverage of sigma notation is provided in Appendix Big E. Emphasis is placed on explaining the meanings of integrals in various contexts and on estimating their values from graphs and tables. Chapter 6, Applications of Integration. Here I present the applications of integration: area, volume, work, average value, that can reasonably be done without the specialized techniques of integration. General methods are emphasized. The goal is for students to be able to divide a quantity into small pieces, estimate with Feynman sums, and recognize the limit as an integral. Chapter 7, Techniques of Integration. All the standard methods are covered, but of course the real challenge is to be able to recognize which technique is best used in a given situation. Accordingly, in section 7.5, I present the strategy for integration. The use of computer algebra systems is discussed in section 7.6. Chapter 8, Further Applications of Integration. Here are the applications of integration. Arc length and surface area, for which it is useful to have available all the techniques of integration, as well as applications to biology, economics, physics, hydrostatic force, and centers of mass. I have also included a section on probability. There are more applications here than can realistically be covered in a given course. Instructors should select applications suitable for their students and for which they themselves have enthusiasm. Chapter 9, Differential Equations. Modeling is the theme that unifies the introductory treatment of differential equations. Direction fields and Euler's method are studied before separable and linear equations are solved explicitly, so that qualitative, numerical, and analytic approaches are given equal consideration. These methods are applied to the exponential, logistic, and other models for population growth. The first 4 or 5 sections of this chapter serve as a good introduction to first-order differential equations, and an optional final section uses predator-prey models to illustrate systems of differential equations. Chapter 10, Parametric Equations and Polar Coordinates. This chapter introduces parametric and polar curves and applies the methods of calculus to them. Parametric curves are well suited to laboratory projects. The two presented here involve families of curves and Bezier curves. A brief treatment of conic sections in polar coordinates prepares the way for Kepler's law in chapter 13. Chapter 11, Infinite Sequences and Series. The convergence tests have intuitive justifications. See page 719, as well as formal proofs. Numerical estimates of sums of series are based on which test was used to prove convergence. The emphasis is on Taylor series and polynomials and their applications to physics. Error estimates include those from graphing devices. Chapter 12, Vectors and the Geometry of Space. The material on three-dimensional analytical geometry and vectors is divided into 2 chapters. Chapter 12 deals with vectors, the dot and cross products, lines, planes, and surfaces. Chapter 13, Vector Functions. This chapter covers vector-valued functions, their derivatives and integrals, the length and curvature of space curves, and velocity and acceleration along space curves, culminating and Kepler's laws. Chapter 14, partial derivatives. Functions of two or more variables are studied from verbal, numerical, visual, and algebraic points of view. In particular, I introduce partial derivatives by looking at a specific column in a table of values of the index of perceived air temperature as a function of the actual temperature and the relative humidity. Chapter 15, multiple integrals. Contour maps and the midpoint rule are used to estimate the average snowfall and average temperature in given regions. Double and triple integrals are used to compute probabilities, surface areas, and in projects, volumes of hyperspheres and volumes of intersections of three cylinders. Cylindrical and spherical coordinates are introduced in the context of evaluating triple integrals. Chapter 16, vector calculus. Vector fields are introduced through pictures of velocity fields showing San Francisco Bay wind patterns. The similarities among the fundamental theorem for line integrals, Green's theorem, Stokes' theorem, and the divergence theorem are emphasized. Chapter 17, second order differential equations. Since first order differential equations are covered in Chapter 9, this final chapter deals with second order linear differential equations, their applications to vibrating springs and electric circuits and series solutions. Ancillaries, acknowledgements. Ancillaries, calculus, early transcendentals, 8th edition, is supported by a complete set of ancillaries developed under my direction. Each piece has been designed to enhance student understanding and to facilitate creative instruction. The tables on pages 21 and 22 describe each of these ancillaries. To the student, reading a calculus textbook is different from reading a newspaper or a novel or even a physics book. Don't be discouraged if you have to read a passage more than once to understand it. You should have pencil and paper and calculator in hand to sketch a diagram or make a calculation. Some students start by trying their homework problems and read the text only if they get stuck on an exercise. I suggest that a far better plan is to read and understand your section of the text before attempting the exercises. In particular, you should look at the definitions to see the exact meanings of the terms. And before you read each example, I suggest that you cover up the solution and try solving the problem yourself. You'll also get a lot more from looking at the solution if you do so. Part of the aim of this course is to train you to think logically. Learn to write the solutions of the exercises in a connected step-by-step fashion with explanatory sentences, not just a string of disconnected equations or formulas. The answers to the odd number exercises appear in the back of the book in Appendix 1 or Big I. I don't know if that's Roman numeral. Some exercises ask for a verbal explanation or interpretation or description. In such cases, there is no single correct way of expressing the answer, so don't worry that you haven't found the definitive answer. In addition, there are often several different forms and ways in which to express a numerical or algebraic answer. So if your answer differs from mine, don't immediately assume you're wrong. For example, if the answer given in the back of the book is the square root of 2 minus 1, and you obtain 1 over open 1 plus the square root of 2 close, then you're right, and rationalizing the denominator will show that the answers are equivalent. The icon with a graph indicates an exercise that definitely requires you the use of graphing calculator or a computer with graphing software. That doesn't mean that graphing devices can be used to check your work on the other exercises as well. The symbols CAS is reserved for problems in which the full resources of a computer algebra system like Maple, Mathematica, or the TI-89 are required. You also encounter the symbol, basically a no-go sign, stop sign, which warns you against committing an error. I have placed the symbol in the margin in situations where I've observed that a large proportion of my students tend to make the same mistake. Tools for enriching calculus, which is a companion to the text, is referred to by means of the symbol capitals TEC in the symbol pink background, and can be accessed in the ebook via Enhanced Web Assign and CourseMate. Selected visuals and modules are available at stewartcalculus.com. It directs you to modules in which you can explore aspects of calculus for which the computer is particularly useful. You'll notice that some exercise numbers are printed in red 5. This indicates that homework hints are available for this exercise. These hints can be found on stewartcalculus.com as well as Enhanced Web Assign and CourseMate. The homework hints ask you questions that allow you to make progress toward a solution without actually giving you the answer. You need to pursue each hint in an active manner with pencil and paper to work out the details. If a particular hint doesn't enable you to solve the problem, you can click to reveal the next hint. I recommend that you keep this book for reference purposes after you finish the course because you will likely forget some of the specific details of calculus. The book will serve as a useful reminder when you need to use calculus in subsequent courses. And because this book contains more material than can be covered in any one course, it can also serve as a valuable resource for a working scientist or engineer. Calculus is an exciting subject just considered to be one of the greatest achievements of the human intellect. I hope you will discover that it's not only useful, but also intrinsically beautiful.